In this video, we'll see how to conduct the second lab cycle experiment, that is CE amplifier. The aim of this experiment is to design and construct a suitable circuit and determine the frequency response and bandwidth of a CE amplifier. So this is the circuit diagram. CE stands for common emitter configuration. So here we are making use of voltage divider biasing because it gives high gain, and these are the components required are the transistor, coupling capacitor, various resistors, emitter capacitor, bypass capacitor, transistor base, connecting wire, breadboard, regulated DC power supply, signal generator and CRO. So this is the transistor. We have to keep this such that the notch come downwards and the terminals goes like this. This is emitter, collector, emitter, base and collector. So this transistor is very small to make the circuit connections. So we are using this transistor base. So I am connecting this transistor to this transistor base such that the emitter terminal comes to this red wire. So this red wire is the emitter, the black one is base and the blue one is collector. So in order to make the circuit connections, we are making use of breadboard. So I am connecting the emitter terminal here, base terminal here. So in this breadboard, this is vertically connected and these rails are horizontally connected. So next we'll make all the connections associated with the base terminal. So next I have to use input coupling capacitor to this basin. So this is vertically connected, so I have to make use of any of these holes that are in this vertical line. So I'm connecting this one end of the coupling capacitor here and the other end here. To this end I have to connect the positive of the signal generator and the negative of the signal generator should be grounded. So next I am connecting the base 2 resistor. This is 4.7 kilo ohm, that is yellow, violet and red. One end I am connecting to the base, the other end I am connecting to the ground. Next base 1 resistor, 22 kilo ohm resistor, red, orange. One end I am connecting it to the base, the other end I am connecting here. To this end I have to connect the 1 kilo ohm resistor from the collector end. Now I have to give the positive of the DC power supply to this and the negative should be grounded. So here it is horizontally connected, so I can make use of any holes within this phi. So next, emitter capacitor. So this capacitor, it has a polarity. The long lead is the positive lead. Positive I am connecting it to the emitter end and the negative I am connecting it to the ground. This is a emitter capacitor, 270 ohm. Two resistors are connected in series to make this 270 ohm. 220 and 47 resistors are connected in series. So here I am making use of two different grounds which I need to connect it separately with a connecting wire. To the collector end I have to connect the output coupling capacitor. To this end I am connecting the load resistor, one end to here and the other end to the ground. And to this I have to connect the probe of the output channel. The negative end should be grounded. So this is the circuit connection. So next I need to apply 0.05 volts, that is 50 millivolts. In order to apply that, I am setting this to 5 volts and I am pressing this 40 dB attenuator circuit so that I am applying 0.05 volts. The frequency, initially I am setting this to 100. So next the DC power supply. So I am setting this to 10 volts and I am switching it on by pressing this set button. So next CRO. So we are applying 50 millivolts and we are getting At 100 hertz frequency, we are getting 0.4 volts. The next is to determine the frequency response of this circuit. So in order to do that, we'll keep on increasing the frequency, and the peak to peak amplitude of the output wave, it keeps on increasing. So the frequency response of this circuit is like this. Till 4 kilohertz, the frequency keeps on increasing. At 4 kilohertz, we will be having 4 volts peak to peak amplitude. That 4 volts is maintained constant till 240 kilohertz. Next, from 240 kilohertz, the amplitude goes on decreasing. So the frequency response of the circuit will be like this. Till 4 kilohertz, the frequency with the increase in the frequency, the peak to peak amplitude keeps on increasing. This is called low frequency range. Next, from 4 kilohertz to 240 kilohertz, the 4 volts frequency is maintained constant. This is called mid frequency range. And from 240 kilohertz, with the increase in frequency, the amplitude goes on decreasing. So this is called high frequency range. So this minus this is a midband gain. In order to calculate the bandwidth, we have to subtract 3 dB from this peak amplitude, and this if we consider as F2 and F1, F2 minus F1 will give us the bandwidth. Thank you.